All right, so welcome to SolidWorks. This is SolidWorks for Maker. If you're an engineering student, you might have regular SolidWorks, but it's basically the same thing. And I'm going to walk you through just like an introduction to the software right now. So as soon as you open it up, um, we're going to go New Part and then File, New Part. And just right off the bat, let's go through some preferences. So while you're working through the class, you might notice that maybe your computer's lagging a little bit, or things aren't running as smoothly as you would like. If you press this little gear icon, or I think if you go to Tools, Options, it's the same thing if you don't have this toolbar set up. And then you look for Performance. There's all these sliders that basically affect the detail and how fast your computer runs. So if you want everything to run slower, if you want everything to run faster, you can sacrifice some detail, slide this over, and you can make everything fast. I recently got a good computer for this sort of thing, so I used to have mine on all like the fastest settings. And then also, for this class, we're going to be working in terms of units. We're going to be working in millimeters. I don't know why mine says custom. If yours isn't on millimeters, just go to Document Properties, Units, and then go to millimeter grams per second. And then you press OK. All right, so to navigate in SolidWorks, the default controls are if you hold down the middle mouse button, your scroll wheel, if you like press it in and then like pan your mouse around, you'll be able to like orbit throughout 3D space. At first it's a little wonky, but you'll get used to it. And then if you want to pan, so just like move left or right, you hold control while holding down the middle mouse wheel and then move your mouse left and right. And then there's zoom also, which is you scroll the middle mouse forward or back. I think by default it might be inverted. Let's see if you could change that here. Yeah, so it's in options, view, reverse mouse wheel, zoom direction. And if you need to get to options, it's tools, options. So just a brief introduction to what SolidWorks is. So SolidWorks is a parametric CAD software. So basically what that means is on the left, you have the feature tree, and we're going to be building features that all have relationships with one another. So that's what parametric means. And basically the advantage of that is if we need to make one update, but let's say we did it all the way in the beginning, if we design in a smart way, which I'm going to show you how to do, you can make one change, you can go back, make one change, and then your whole model will update and nothing will break and everything will update. And it's a very efficient way to build like robust models, basically. As opposed to other software like Blender, which is free, where it doesn't have any like history where you can like edit features. You kind of have to like just build as you go. And if you make a mistake, you kind of have to like go back and fix it or save different iterations. Anyways, so let's get right into it. I'll just explain some of the basic features just to get your feet wet, but we'll go through most of the features like just by doing it through the class, so I don't want to talk too much about it. So the main way that you build things is you start in 2D and you build a sketch, and then you do something to that sketch to bring it into 3 dimensions. So let's go through that process right now. So if on the top toolbar, if you go to sketch, and then it'll ask you what plane you want to sketch on. So there's 3 planes that you start out with. There's the front plane, there's the right plane, and the top plane. We'll just do front plane for now. And then they give you all these different features or buttons that you can press. So there's a line, that's self-explanatory, right? You could just click. And then I always press escape to exit out. If you want to, let's say you want to, well, I'll go through the other features first. There's a circle. So this one, you would pick the center point of the circle and then you click again. And then I'm pressing escape to cancel out. There's rectangle. Same thing. Pretty self-explanatory. And then there's like other different ways that you can make rectangles. So you could like start in the center. You could If you're trying to build like a rectangle at like a weird angle, this is like 3 points. So you click once, click twice, and you can do something like that. There's arcs. So with arcs, you click once, click twice, and then you like bring out the center of the arc. I don't really use these other ones. Sometimes I'll use splines. So splines are just like curves with a bunch of different points. So you click once, click twice, and then it starts to like bend. And you could click escape and then modify it. And then there are these like little handlebars to adjust like the radius of curvature or whatever. Those are the main things that I use. Trim entities is really useful. So let's say, I don't know, let's say whatever you're working on, there's a sketch and it's like this and you have like overlapping lines. Trim entities, if you click trim entities, I'll have trim to closest on, and then you just, this little scissor icon comes up on your cursor and you just click whatever's extra and then it goes away. Also, in terms of like key bindings and shortcuts, I make my trim T. I don't know if that's how it starts out. So let's see, how do I create a shortcut? Okay, so you go to tools and then you go to customize at the bottom. And then if you go to shortcut bars, oh, it's keyboard. And then you search for whatever feature you're looking for. So trim would be the one that we're working with here. There's a couple of different ones. You kind of, you're under a sketch tool, so it'd be this trim, and then you just click here and then you type whatever shortcut you want. So that's trim. There's also in here extend, which is like kind of similar. So extend is like, let's say you want this to be on this line, but it's not exactly there. I press E, that's what I made the shortcut for extend, and it just pushes it over. And then there's convert entities and offset entities I use literally all the time. So let's say you have this like circular object, right? And you create a sketch. You want to create a sketch on this surface. Let's say I want in my current sketch, I want to bring in the exact like perimeter edge of this circle. I'll click convert entities and I'll basically just take exactly that. So if I just click once on the face, you could also click the edge, same thing works. It'll take exactly that edge. And then we could do whatever we want with it. So let's say from this edge, we also want to offset that edge. I don't know. Let's go the other way, 10 millimeters. Boom. Now it creates a relationship between those two things. So that's what I was talking a bit about before. Relationships between all your features. So let's say if I wanted to change this to 15, I just press enter and it'll auto update. So let's go back. I'll leave out the other things for now because we're gonna go over that later. But that's just a brief introduction to like sketching features. So in terms of your other features, so once you have, let's say you have your sketch, right? So that exists on the left here. And then let's say you want to bring that sketch out to 3D now. So the most common one is extrude, which basically just means like pull it out into 3D and add some thickness. So if we click our sketch and then you click extrude, there's the easiest way would be blind, and it's just like type in the thickness that you want. So let's say 25, and then you have a cylinder. You just click OK. In this dialog box, there's like a bunch of different versions of this. Like instead of saying 25, let's say you want to go up to like a surface that is like kind of curved. So you don't want to just like pull it out in one direction. You want it to like go up to the curved surface and then stop. That's what up to surface means. There's up to body. Mid plane is like in both directions. Also, another way to modify how much it pulls out is you just like pull on this arrow and then it'll come out. That's extrude. That's like the easiest one. Revolve is pretty interesting. That's for creating like circular objects. So if I create a sketch on the front plane, so with revolves, you always need a center line. So that's like what it's going to revolve around. So if I click that and then I go, so if I create the line, create a vertical line, and then if I left click the line on the left, or if I right click, this button means construction geometry. So that's like not an actual line. That's just like something that you want to reference or like use as like a tool in your sketch, but it's not going to actually think it's like a solid line. So let's create a center line and then make it construction geometry. And then let's say I'm going to take the spline tool and I want to make this like crazy organic shape. Actually, don't make this construction geometry. Let's make it solid. So now we have a 2D shape that's like closed because we had the center line, then we closed it with the spline. If you go to revolve, and then you just click the center line, what we're revolving around, and go boom. Now we have this like organic looking shape. There's some other features here, but extrude and revolve are probably the most common. I'll go a little bit. We'll use loft in this course. I don't know if we'll use sweep. Sweep is basically like, let's say, I don't know, you have this like serpentine path or whatever, and then you have another sketch that's so like sweep will basically like bring a 2D sketch all around some like perimeter path. Like it'll snake it all around and like pull it through, and then you could click OK and make a solid. And then there's some other features we'll go through the class, but I just want to explain to you some of the basics. Oh, and then the last thing I want to explain is so while you're making a sketch, there's something called constraints. So basically, like if I make a line in space, right, and then I click it, on the left it'll say like, oh, add relationships. So do I want this line to be vertical? If I press vertical, it'll snap to being 90 degrees up. If I want it to be horizontal, I could do the same thing, right? And then there's a couple of other things you could do. Let's say if I click this point and then I click this point, and let's say I don't want to like drag them, I just want them to like be on top of each other and like merge. There's literally merge, and there's also coincident. Not really sure what the difference is. Oh, I guess merge is like a point to a point, but you could do like a point to just the line, and that would be coincident. So like merge is a type of coincident, I guess. Coincident can be like anything on top of each other. And then there's a couple of other things like circle. You could do like the center of the circle to this line, and then you could make it like the center of that line, so it like snaps right on top of it. So those are constraints. Basically, constraints are like how you define your lines in your sketch in relationship to one another. So that's just a brief introduction about the software and some of the features. The best way to learn this is to build something. So once again, I don't want to confuse you or overload you with information. We should just start modeling. But I just wanted to get your feet wet so you make sure you understand what you're doing. A couple of other random things that I just want to include. So if there's a time where like you know what the feature is called, but you don't know where it is, on the top right, if you go to search commands, you just click it, and then you could type, let's say I didn't know where extrude was. You could just type it out, and then boom, it'll bring up that feature. Sometimes I use that because I forget like where random features are that I haven't used in a while. Okay. And then the other thing I want to show you guys is, so I already have my model finished for this, but I'm going to work with you while we build it just to make sure you guys understand. But I want to explain a concept to you right now. So, so this is my final design file, right? So you can see like, oh, there's not that many features, but I like to organize all of my features so it's like super clear in my head. So like these are all the features I use to make the head, and then I put it in a folder and like title it whatever it is, and then this is the jaw, the body, the back, and you have all these different pieces, right? So anything that I am like designing to be printed and like maybe they're like touching each other or like they have relationships to each other, I'm building all in one file. And I call that my master file. So this is Dragon Master. And then in terms of like the naming convention for it, I'll do rev is like the revision. So I'll start at 1, and then like anytime I make a change, I'll I'll increase the rev by 1, and then like so I'll have rev 1 as my original files. And then let's say I want to make a big change. Let's say I want to make the whole thing half the size that it was. I'll package all the files and take them and make it rev 2. So now I can make all my new edits in rev 2, and then let's say I was like, "Oh, how do I do this one part from rev 1?" I still have the rev 1 files to reference back on. So I could open the rev 1 files, see how I did something, and then go back to my rev 2 files and start making changes. So that's like a really smart way to model, because you're like saving revision history for all your files, and you can see how you did things in the past, so you don't like, because if you keep saving over the same file, you may want to like reference back on something that you missed. So this is a great way to do it. And then the reason why the master is so good is because sometimes you'll have parts that, like, let's say you have one part and it's like it needs to talk to or like go right up against this like really curvy line, right? So you have this one part that's like really curvy, and then you have another part that should be on the other side of the really curvy line. Like, if they were two separate part files, it can get a little confusing having them meet at the same boundary and like having like a clean relationship between the two. So for that reason, sort of, that's like a simple example, but that for that reason, it's a good way to create all the parts that like are actually going to be printed in one file and call it master, and then save each of the part. Like, I still have different, this is one part file, but I still have different components. So like you just save them as different solid bodies, and if you open this folder, like I could like hide all of these things and then say I only want to work on the headpiece or the skull. Boom, I just hide everything else, right? I'll just show it, keep it shown for now. So you can still do that if you want. But I think this is a great way to model because you're keeping everything in one place. If you have like complex geometry, multiple parts need to reference, it's really, really easy. And then I'll also show you guys how to like save files later. But this is a great way to model. So your part file or your component file, I keep one master for all my parts. And then I'll show you guys my assembly file. So my assembly file is going to be like, in this design, we're going to have electronic components, right? So I took like existing electronic components from GrabCAD because they've already been designed before. It'd be silly to try and like remake it myself to like use as a reference in my model to like mount it to my dragon or like build pieces around it. So all of my parts that I'm actually designing that will be printed, that goes in the part file that's a master. And then I bring that part file into my assembly, which is this top thing. And then all of these other things are like components or other pieces of hardware that are like interacting with my plastic parts. So that's like a really good way to model to keep everything clean and organized. I'm going to walk you through exactly that, but it's important to like understand from like a higher level, like how we're going to get there. And then the last thing I want to show you guys is the thing where I talked about where like you have rev 1 of files and then you bring it to rev 2 and then you still have the rev 1 files to like look back on later, but you start editing in rev 2. So SolidWorks is great. It makes it super easy because like you have relationships between all these features, right? So like, how do you make it so that like all the features in this one rev 1 file are all packaged together? You bring it to rev 2 and all the rev 2 files keep their relationships to each other. You don't want those relationships to break, right? So SolidWorks is a super easy feature for that called pack and go. And I recommend you guys model this way. Like while you're working through the course, like let's say you start out in one version, you did something wrong, you should rev it up to the next thing and make your edits in the new version. So the way that you do that is, so my assembly file is like my top level part because it has my master and all the components with under it. So in order to package and go, it's called package and go. So you go file, pack and go. and then you just pick wherever you want to save it. So I have a folder called SOLIDWORKS files with all my projects, and then I'll go to this is intermediate 3D printing course, and then I have all my revs. I'm just showing you guys my file structure, and I recommend you follow the same type of file structure. So here, if I wanted to make a new rev, I'd make a new folder called rev6 because we're at 5 right now and we're going to 6. And then you click select folder. And then for my assembly and my master file, at the end of the files, I include the rev number. So under new file name, you just double click. And then instead of 5, you make this 6. And instead of 5 for the master, you make this 6. And then I like to flatten everything to a single folder. And then if you want to go through with this, you just press save. But I'm not going to do that because I like my files right now. So yeah, that's like a good way. That's like the structure of how I model and how we're going to be modeling in this course. It keeps everything organized and clean, and all your relationships between all your different parts will update super quick. It's a great way to model. So yeah. So that was a lot for one video, but I will see you in the next part. All right, so sometimes your parts are going to break, and basically that just means that like you move something or delete something, and another part of your design was like referencing that part that you got rid of. SOLIDWORKS doesn't know how to like reconcile that and like update your part accordingly. So there's 2 different types of like breaks or failures. It's a red error or a yellow error. The red error usually means like your features are broken, like it's missing something. They don't know how to update. Yellow error is just like your part still works, but like whatever you were referencing like no longer exists. And I'll try and show you an example of what that looks like. So let's say I'm working in my design and I had a sketch that, I don't know, uses this sensor, right? It's like referencing this sensor, right? And then for whatever reason, I delete my sensor. My whole model turns yellow. And basically what that means is if you click it, this is what I call a yield error. It might be something different in SOLIDWORKS, but that's what I call it. Unable to offset one or more sketch entities. So if we go into it, we can see that everything is, highlighted yellow instead of our previous black lines. That's basically just telling us whatever we were referencing before is now gone. So there's a couple of things you can do. You can just like delete it all and start from scratch. You could, if you click these relationships, you could just click them and then press delete. And then you could also select all. You could also do display delete relations and then shift click all of these and then press delete all. And then now you have like the blue lines. Basically, these lines are now what it was prior, but without any relationship. So if like you move something, this won't move accordingly. So you'll have to like update this with dimensions. And then let me think of like a red error. Oh, also sometimes the reason why this happens is like, so say you sketch on one plane and then that plane moves and it doesn't know where to go, or you got rid of that plane. You could, so if you're in here, so the reason for yellow errors is either like in your sketch, you took something as reference that's now gone and you have to fix that by doing what I just showed you. Or you may open your sketch and everything might look fine. And the reason for that is, if it's still yellow, is that the plane that you sketched on is now gone or missing. So if you right click your sketch and then you click edit sketch plane, this might be yellow and then you have to update whichever sketch you're sketching on, whichever plane you're sketching on. And then maybe an example of like a red error is, let's say I try and like move all these features, like, I don't know, can I do this? So, okay. So now this feature broke because a red error is like more of a big deal. It'll like stop your model from working and it'll like totally forget what it was working with prior. So this is a good reason why you should be revving up your models also, so you have something to reference back on if something breaks and you can't remember what happened to it. So yeah, a red error is more of just like, okay, something went wrong. SolidWorks doesn't understand how to update something, and you need to go back and like basically rebuild the feature or fix whatever's broken. And then yellow error is just like, oh, like a reference is missing. Like your part's still good, but like it's not exactly sure how to like make it perfect. Also, so we're gonna start designing spike at the end of each of the parts or videos at the uh, completion of each of the videos. I'm gonna save out my files, and you guys can download them below. So if you want to open them and see how I did something and see how it matches up to your parts, you can do that. Just make sure, obviously, that you're also trying to build it along with me to make your own, to really learn all like the tools of the software.